Welcome to this brief video from R.L. Deppman Company on some of the basics of primary-secondary piping. Here's a small primary-secondary loop. The thing that makes it primary-secondary is the common pipe. The pipe between the supply and the return before it goes to the coil. We do not have to have the flows of the primary and secondary equal in a design, but we're going to assume they are for this brief discussion. The temperature control valve is wide open, so the flow into the bridge piping is 100 GPM, and the flow from the bridge to the coil is 100 GPM. Since there is no leak in the system, the return flow rate must be the same. When we analyze primary-secondary systems, we use a couple of fundamental rules, and one is the conservation of mass. Characterized here as the law of the T, the flow rate, or GPM entering a T, must equal the flow rate leaving the T. I know this is pretty simple math, but it'll be clear in a little bit why I'm doing this. So if we look at the law of the T, I've got 100 GPM going into the T from the main. I've got 100 GPM leaving the T going to the coil, and therefore I must have 0 GPM in the common pipe. Let's assume that the design is based on a 40-degree delta T in the coil and also in the primary. So I have a 180-degree supply temperature and a 140-degree return temperature. Now let's look at the law of the T and see what happens as far as the temperature goes. The second law of the T is all about conservation of energy. If we assume the control valve throttles, and let's say it's throttled down and the primary flow is only 50% or 50 gallons per minute. The coil remains at 100 GPM. The common pipe must be flowing 50 GPM of return water from the coil into the T. The flow remains constant through the coil, but what happens to the supply temperature to that coil? We have conservation of mass since the flow rates add up correctly. What about energy? Let's look at the temperatures. We know we will have mixing at the T. I have 180 degree coming in with 50 gallons per minute and 140 degree coming in with 50 gallons per minute. So I have 100 GPM leaving at some temperature between them. This may be very obvious on this particular example. It gets a little more difficult if the numbers aren't 50-50. So I've got 50 times 180 plus 50 times 140 going into the T. I now have 100 GPM of what temperature coming out? So if I just do the math, 9,000 plus 7,000 equals 100x. And the answer is going to be 160 degrees F. So the two-way valve throttles more. The secondary flow rate remains constant at 100 GPM, but the supply temperature will drop again because the primary flow rate is less. We'll be mixing more of that 140 degree water in that T. When the two-way valve starts to open, the flow rate in the secondary remains constant again, but the supply temperature to the coil will start to rise, and it will continue to rise until the control valve is wide open and we're flowing 180 degree water directly from the primary into the secondary. Thank you for listening to this short excerpt from our primary-secondary class. If you want more detail, visit our website or register for the Bell and Gossett Little Red Schoolhouse primary-secondary classes. Thank you.